Hi there. In this video, I'll show you how to easily display terrain from GeoTiff files on a 3D map. We'll be using WSL with Ubuntu. My name is Michael, I'm a developer and the creator of OpenGlobus, a JavaScript library for 3D geospatial visualization. If you find this interesting, make sure to subscribe, leave a like and drop a comment. It really helps support the project. Let's start by setting up our environment. First, we will clone the Gevlich repository from OpenGlobus on GitHub and place it in a folder named Gevlich. Gevlich is a collection of useful scripts for generating terrain tiles from GeoTiff files. It uses tools like OpenDrawMap, RasterioGDAL and RGBFi, so we don't have to do everything manually. To run the scripts we need Docker. If you don't have it installed yet, do that first. I already have it set up, so I just need to build the image following the instructions. Next, we create a source folder where we'll place our GeoTiff terrain files. If you need sample files, you can find links in the project documentation, the link is in the video description. You can also preview the files in QGIS to check their location on the map before processing. Here's what one of our GeoTiff files looks like. Now we need to decide where to store the generated terrain tiles. In this example I will place them in a terrain folder inside our project, but in real-world applications this is usually a URL to an external source. Now we're ready to generate the tiles. The command we need is in the Gevlich GitHub documentation. We will use the version that takes a local folder as a source. From the Gevlich folder, run the tile generation command. We specify the source folder path, the destination folder path and the zoom levels for the tiles. For terrain with 2 meters accuracy, the maximum zoom for square 256 pixel tiles will be approximately level 18. Processing time depends on the data volume. Once the script finishes, the destination folder will contain the generated terrain tiles. These are PNG files with elevations encoded in RGB colors. The files are organized in folders by zoom levels. Now let's display our terrain on a 3D globe. First, we need to build OpenGlobus. We clone the repository, install dependencies with npm install and compile the library using npm run build. In the lib folder we will find the compiled OpenGlobus build. We move the necessary modules into our project's terrain folder. For convenience, we can use a template from the examples on the OpenGlobus website. You can also use OpenGlobus NPM package, but in this case I'll show you how to connect the modules directly. Let's initialize our project with npm init. We add an HTTP server and configure it in package.json. Then we start the local server using npm run serve. Now our app should be accessible at the address shown in the server output. Let's check how our terrain tiles look. Now it's time to open your favorite IDE. I'll use Visual Studio Code. We create an HTML file, index.html, and write the code. This will be a simple web page that we run on our local server. We can take the code from the high-resolution terrain provider example on sandbox OpenGlobus.org. We configure the RGB terrain provider, setting the path to our generated tiles. We also add path for local resources like fonts, city night masks, and ocean specular highlights. This step isn't essential, but it makes the globe look much better. Add an HTML container for the globe, taken from the example as well. And we adjust the HTML file header, making sure the CSS paths are set to local ones. Next, we copy the OpenGlobus library into our project folder. We only need the CSS, the ESM module, and the additional resources folder. Everything looks good, and let's start the server from the WSL terminal using npm run serve. Now we open the browser at the specified local address and check how the terrain is displayed on the globe. This is what it looks like. You can explore the terrain in more detail using the Terrain Profile plugin, analyze ground intersections and observe elevation changes. I leave a link to the example in the description. That's all for today. If you have any questions or suggestions, feel free to leave a comment, subscribe, leave a like and stay tuned for more videos. All the links to the code and documentation are in the video description. See you next time.